What if I told you that, for the first time in human history, we are watching planets being born? Right now? Not imagining it, not simulating it, actually seeing it. 1,300 light-years away, around a newborn star, astronomers have captured the exact moment when cosmic dust turns into solid matter, the same process that created Earth, Jupiter, and every world in our solar system. This isn't science fiction. This is our origin story, caught on camera. For as long as humans have looked up at the night sky, we have asked the same fundamental question. Where did we come from? Not just as individuals, not even just as a species, but as a planet, a solar system, and a part of the universe itself. How did Earth form? How did planets like Jupiter, Mars, and Saturn come into existence? And what did the very first moments of our solar system actually look like? For centuries, these questions belonged to philosophy. For decades, they belonged to theory. And now, for the first time in human history, they belong to direct observation. An international team of astronomers has captured something extraordinary. The earliest moments ever observed of planets beginning to form around a star beyond our sun. This discovery is not just another step forward in astronomy. It is a time machine, offering humanity its clearest window yet into its own cosmic origins. Before we begin, make sure to subscribe to the Beyond the Event Horizon channel and like this video. The story begins far from Earth, about 1,300 light-years away in a dense star-forming region of space. There, nestled within a cloud of gas and dust, lies a young star known as HOPS 315. By cosmic standards, HOPS 315 is an infant. It has only recently ignited, beginning its life as a true star. And like most newborn stars, it is surrounded by a swirling disk of material. Astronomers call this structure a protoplanetary disk. These disks are made of gas, dust, and microscopic grains, the raw ingredients for planets. They are chaotic, turbulent environments, shaped by gravity, radiation, heat, and time. For decades, scientists have known that planets are born inside these disks. They've seen disks with gaps carved by young planets. They've seen disks with fully formed planetary systems. But until now, no one had ever seen the very first step. The moment when dust becomes solid, the moment when chaos becomes structure, the moment when planets begin. To understand why this discovery is so important, we need to understand the problem astronomers have faced for generations. Planet formation is not a simple process. It begins with tiny particles, smaller than grains of sand. These particles collide, stick together, and slowly grow. Over time, they form larger and larger bodies, eventually becoming planetesimals, the kilometer-sized building blocks of planets. From there, gravity takes over. Planetesimals collide and merge, forming planetary embryos. Those embryos grow into full-fledged planets. But here's the challenge. While scientists have observed disks, and while they've observed planets, they had never observed the transition between the two. The moment when hot gas turns into solid mineral grains, the very first solid matter from which planets are built. That moment was theoretical, until now. This groundbreaking discovery was made by an international team of researchers representing 8 institutions across 5 countries. Among them were scientists with strong ties to the University of Michigan, a leading center for astronomical research, the James Webb Space Telescope, and the Atacama Large Millimeter Array, ALMA, in Chile. Together, these instruments gave scientists the ability to see both the chemistry and the structure of a newborn planetary system in unprecedented detail. The James Webb Space Telescope, launched in 2021, is humanity's most powerful space observatory. Unlike Hubble, which sees primarily visible light, JWST specializes in infrared light, allowing it to peer through dust clouds and detect heat signatures from distant objects. This makes it uniquely suited to studying young stars and protoplanetary disks. JWST can identify specific molecules and minerals based on how they absorb and emit light. ALMA, on the other hand, is a network of 66 radio telescopes located high in Chile's Atacama Desert. ALMA excels at mapping cold gas and dust, revealing where materials are located and how they move. By combining JWST's chemical sensitivity with ALMA's spatial precision, astronomers achieved something never done before. They watched solid materials begin to form in real time. At the heart of this discovery lies a simple but profound substance: silicon monoxide. In the early stages of a planetary system, temperatures near the star can reach thousands of degrees. At these temperatures, most materials exist as gas. But as the disk cools, certain minerals begin to condense into solids. In our own solar system, these earliest solids are preserved inside ancient meteorites. These meteorites contain crystalline minerals rich in silicon monoxide, formed at extremely high temperatures over 4.5 billion years ago. By dating these minerals, scientists have determined when the clock started on our solar system's formation. Now, for the first time, astronomers have found the same process happening around another star. In the disk around HOPS 315, silicon monoxide exists in both gaseous and solid crystalline forms. This means the system is caught at the exact moment when gas is turning into solid matter. The birth of planets has begun. One of the most remarkable aspects of this discovery is where it is happening. The silicon monoxide minerals are forming at roughly the same distance from HOPS 315 as similar materials formed from the Sun, near the region where Earth would eventually emerge. Logan Francis, a postdoctoral researcher at Leiden University, explains, "We're seeing these minerals at the same location in this extrasolar system as where we see them in asteroids in the solar system. This makes HOPS 315 more than just another star. It is an analog, a stand-in for what our own solar system looked like billions of years ago," according to co-author Merrill Van 't Hoff, who began the project as a University of Michigan postdoctoral researcher. This system is one of the best we know to actually probe the processes that happened in our solar system. In other words, HOPS 315 is not just forming planets, it is telling our story. Once these first solids form, the process accelerates. Dust grains collide and stick together. They grow from microns to millimeters, from millimeters to centimeters, from pebbles to rocks. Eventually, gravity takes over. Within a relatively short cosmic time, perhaps just a few million years, these materials form planetesimals, the building blocks of planets. In our own solar system, these planetesimals became Earth. They formed the core of Jupiter. They shaped the asteroid belt and Kuiper belt. Now, astronomers are witnessing that same chain of events begin elsewhere in the galaxy. This discovery fundamentally changes our understanding of planet formation. For the first time, astronomers can test theories with direct observations. Compare models with real data. Study planetary birth as it happens, not just after the fact. It also opens new possibilities. How common are Earth-like planets? Do all planetary systems form the same way? What conditions are necessary for habitable worlds? By studying systems like HOPS 315, scientists can begin to answer these questions with confidence. This research represents the beginning of a new era in astronomy. With JWST and ALMA, scientists can now observe planetary systems at every stage of formation, study the chemistry that leads to rocky worlds, understand how solar systems evolve over time. HOPS 315 is likely just the first of many such discoveries. As telescopes become more powerful and techniques more refined, astronomers expect to find dozens, perhaps hundreds, of newborn planetary systems. Each one will tell a slightly different story. Each one will help us understand our place in the cosmos. Every atom in your body was once forged in a star. Every rock beneath your feet began as cosmic dust, and every planet, including Earth, started its life in a swirling disk of gas and light, much like the one surrounding HOPS 315. For the first time, humanity is not just imagining that beginning, we are seeing it. Across 1,300 light-years of space, across billions of years of time, we are watching worlds being born. And in doing so, we are finally beginning to understand how we came to be. If you enjoyed this video, subscribe to the channel and like the video.